Welcome to monobiology. Today we're going to look at an important concept of this course, and that's called mutations. We've been studying over the last couple of weeks the idea of DNA, what it is and why it's important, as well as protein synthesis and what it is and why it's important. And so now we're going to look at a little bit what happens when something goes wrong with either of those two processes. Now, everybody has a picture in their mind of what a mutation is. Could be like this one here, which is the Chernobyl piglet. If anybody's familiar with what happened in Chernobyl, they might understand why the piglet looks like that. And then, of course, there's the lighter side of mutations, like the Teenage Mutant Ninja Turtles or the X-Men. Either way, everybody has a picture of what a mutation is in their mind. Hopefully we'll clarify some of these misconceptions, although this particular mutation is true, these ones not so much. And we'll get a better idea of how these happen and how they can affect an organism. So first of all, the definition of mutation is as follows. It's a change in the normal DNA sequence of an organism. That's it. That's what the definition of a mutation is. It's a change to the normal DNA sequence of an organism. There are various types of mutations that we're going to look at in this lesson. Let's move to the first one. Point mutations. Point mutations are single substitutions that occur along the DNA line. Now in this particular lesson, we're going to use this sequence right here, and I want you to copy this down in your notes, as the normal DNA sequence. Okay, so this sequence right here that I'm highlighting for you right now, this one, is your normal DNA sequence. Okay? And we're going to use the exact same sequence as we go through each of these different types of mutations. The ones underneath are going to be the mutated DNA sequences. Okay, so in this particular instance, this part right here that I just highlighted is the thing that was changed. Okay, so it's a point mutation because it occurs at a specific spot. It's also known as a substitution. Now, there are many different types of point mutations, as follows. Okay, so let's say, for example, we take this sequence right here. Okay, and let's pretend that for some reason that particular thing gets changed. Okay, so here in this little chart represents a little bit about what could happen to this particular sequence. Okay, so here's the normal sequence. The messenger RNA would be AAG. And that particular AAG, if you use your amino acid wheel, should code for an amino acid called lysine. No problem, right? Well, here's what happens if different parts of this codon are changed, or in this DNA sequence are changed. If the C gets turned into a T, we end up with the mRNA AAA. Notice, using your amino acid wheel, that also codes for lysine. That type of point mutation is called a silent mutation because nothing changes. Other than the DNA sequence, of course. So the DNA sequence changes, but the messenger RNA still causes the ribosome to put lysine in that particular spot. So it doesn't alter the amino acid sequence of the protein that we're trying to build. All right, the next one. a nonsense codon. So if the first T of this particular sequence, TTC, is turned into an A as our point mutation, that creates the mRNA codon UAG, which is a stop codon. That is called a nonsense mutation. Then we have the last one, which is called a missense mutation, which is where one change causes a change in the amino acid type. Okay, so we have a silent mutation where the amino acid stays the same, a nonsense mutation where the amino acid turns into a stop, and a missense mutation where the amino acid changes. Each one of these particular mutations fits under the point mutation because all we're doing is substituting one letter, one nucleotide, and that causes a mutation. The next type of mutation is called inversion. Now in inversion, a sequence of DNA switches or gets put backwards. So in this case, again, we have our normal sequence of DNA. It's the same one. I want you to copy it down again. And in this particular case, it's this sequence right here that is different. Notice that the original three letters were A, G, C. This is written backwards, C, G, A. A sequence, and it doesn't have to just be one codon, it can be a whole sequence. The sequence has been inverted or flipped back to front. Now here's what I want you to do. I want you to go ahead and I want you to take this normal sequence of DNA and I want you to turn it into messenger RNA. And once you've turned it into messenger RNA, I want you to go ahead and find the amino acids that go along with it. Then I want you to do the same thing to this sequence of DNA to show how this inversion has changed the polypeptide that would be built during protein synthesis. Okay, so you're going to take this sequence, you're going to transcribe it into mRNA, and then you're going to translate it into amino acid sequences. And we're going to do that for the other types of mutations that we're going to talk about here as well. The next types of mutations fit under the category of frame shift mutations. The first type is called deletion, and that is where a nucleotide from the DNA gets removed, or if you prefer, deleted. In this case, we've deleted the T that was supposed to go right there in between the G and the C. Okay, so here's my normal DNA sequence again. This is my new DNA sequence. Alright, I want you to go ahead and do the same thing. I want you to convert this into messenger RNA and then amino acids. You don't have to do it again, you've already done it once. But I want you to now take this sequence and do the same thing, which is converting it into messenger RNA and to the amino acid sequence. Insertion is when a nucleotide is added to the DNA sequence. As you can see, this T was not here. So it's been added. That's an insertion mutation. I want you to take this sequence and I want you to convert it into messenger RNA and then again into amino acid sequence. Now, these mutations are called frame shift mutations because it shifts the frame of reference. Okay? In this particular normal DNA sequence, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 codons. Great. In this particular sequence, we have 1, 2, 3, 4, 5, 6, 7, 8, and 2/3. Doesn't quite match up. But notice, this goes TAC, GTC. This goes TAC, which is fine, GCA. Because that T isn't there anymore, my codon frame of reference is now shifted back in this direction. And now every codon that I read subsequently will be different than it was supposed to be in the original DNA. And the same thing happens down here. My frame of reference in this one, where I've inserted one, has been shifted that way. And every codon that comes after that will be different than the original codons that were intended in the normal sequence of DNA. Mutagens are mutation-causing agents, and there are three types. One, we have viruses. Two, certain types of chemicals. And three, we have radiation. And these are the three known mutagens, things that can cause mutations. They also, all three of these, can be called carcinogens, and carcinogens are cancer-causing agents. The one that is the most common and most detrimental, as we saw with our Chernobyl pig, is of course radiation. Radiation seems to be the one that can cause the quickest and the most damage, at least in animals. Chemicals can too, though. Things like smoking cigarettes can be very bad for our health and can also cause mutations in our lung cells that can give us lung cancer. We'll talk a little bit more about that in class. That, in a nutshell, is an introduction to mutations. Please bring your questions to class. Here are the references for the pictures in this video.